Okay, you might remember from the last time we did this that this kind of looks like the base is an equilateral triangle, but we don't have any 30, 60, 90 markings on it that would tell us that. So, what we do know is that this little guy is going to be half of the 13. So, what is that side? 6.5. Okay. So we had to use the Pythagorean theorem to get our hypotenuse because we need the perimeter of the base in our formula, right? Okay, did we already do the volume part?
Yeah.
Okay. Can we just remind ourselves how we got the volume real quick? Okay, so we did the big base times the linear height, and how did we get the big base? 1/2 times base of the triangle times height of the triangle, right? So what was the base of the triangle? 13, and then the height of the triangle, 11. So this is all our big base. And then we have to multiply by the height of the triangle. So 15. What did we get? 17 what?
1072.50.
0.50?
Yes.
Okay.
1072.50.
Thank you.
C squared.
Sorry, everyone's talking at once and it's really hard to hear. Okay. All right, so for the surface area, in order to find all of these lateral faces, the area of these lateral faces, we need to know what this dimension is, right?
Yeah.
Okay.
So we have to do A squared.
Yeah, so we're doing 6.5 squared plus 11 squared equals our C squared. What do we get?
6.5. It's 42.25.
And then the square root. Can you do a power 0.5? 12.77. That's what I remember. So it's almost equilateral, but not quite. Okay. So surface area. Do you just want to add up all the faces, or do you guys want to use the formula? Okay, you're welcome to add up all the faces, see if you get the same thing that I get. Okay, so we're doing, oh my gosh, what is it?
2 pi r.
No, that's for a circle. I'm having a brain fart. Okay, so the lateral area is just going to be our 3 rectangles, right? That are the sides of our triangle. The lateral sides, lateral faces, right? Yeah. Okay. So we've got one of them that's 13 and another pair that are 12.77 and 12.77, right?
Correct.
Okay. And then what is this dimension for that rectangle? The what? 15. Okay. So do you see that the width of this massive triangle is just our sides added together from our base? That's just the perimeter of the base. Okay. It's going to be in my way, so I'm erasing it. So I'm doing 13 plus 2 times 12.77 times 15. So this is our P, this is our height, and this whole thing gives us our lateral area. Okay, that's just the lateral area. What do we still have to account for? The two bases are triangle bases. So we have to add on the bases. All right, well, we already have that. It's in this formula right here. It's just 1/2 times 13 times 11. So this is our, whoops, how many of them do we have?
2.
Okay, so I forgot to multiply by 2. That's our two bases. So what happens with the 2 and the 1/2?
They cancel each other.
Yeah. Okay, crank it out. What do we get?
741.
Okay, 7 what?
721. 21 feet squared.
Is there a decimal place after the 1?
Oh.
Okay, so if it's telling you to the nearest hundredth and you don't have a hundredth, you just put a 0, right? Okay, any questions about that one? Okay, here we go.
I got 4,000. So.
Did we mess it up?
Okay, hold on.
Okay, we did it right. All right, next one. Okay, we've got 3,500 cubic centimeters of clay. How many cylindrical columns can we make from the clay if each column is 12 centimeters tall and has a diameter of 8 centimeters? So basically, we got to know how many of these cylinders can we get from this lump of clay, right? Wouldn't it help if we knew the volume of one cylinder?
Sure would.
Okay, so how am I going to find that? All right, what is the radius of this one cylinder? Okay, if the diameter is 8, R is 4. Okay, what is its height? Okay, so this is a review problem. So we have to take the base and multiply it by its height. Okay, so we need the base area. What would that be? Okay, pi r squared. Okay, times the height of the entire thing. 12. Okay. Let's round at the end. What do we get? Okay, 192 pi. This will be centimeters cubed. All right, now, how do I figure out how many of those are in that? Yeah, I got to divide the volume of the lump by the volume of a cylinder to figure out the number of cylinders I can get. Okay, so we've got 3,500 divided by 192 pi. Make sure that you put the 192 pi in parentheses. Otherwise, it will divide by the 192 and then multiply by pi, and you will be very wrong. Does this make sense?
Yeah.
Because this fraction bar, the way that I have it written right now, is a grouping symbol that says simplify the denominator first and then divide into the 3,500. Okay, 5 point what? 8 what? 0.02. Okay, to me, I'm interpreting this as like how many whole cylindrical columns. So is this a case where we like round up to 6 whole ones, or where we just like truncate to 5? Okay, we're gonna go to 5. Good. So we can make 5 whole cylinders. from 3,500 centimeters cubed of clay. Okay, everybody's brain happy? Okay. All right, we have to draw the net of a triangular prism, a cube, and a rectangular prism. Okay. Triangular prism. Do we want to take it easy on ourselves and just make an equilateral base? Okay. It's Monday. We're going to be slackers a little bit. Oh, easier said than done, right? Oh my goodness. Okay, we got a triangular prism. So the triangle is talking about the bases. Okay, a cube. Do your best with the cube. Oh, we're drawing a net. Oh my gosh. Okay, it's definitely Monday. Wow. Thanks, guys. Okay, so I need 4 sides to wrap around the lateral sides, and then I need a top and a bottom, right?
Right.
Okay, so you can make your top and bottom like this or wherever. Just make sure that when you fold it, you don't get any overlapping sides. Okay, rectangular prism is going to be kind of like the cube, but we have lopsided sides. Okay. You don't need to struggle. Watch me struggle, do it. Okay, so when you're doing these, you just want to make sure like that these sides match up, obviously, because that's where you're going to fold it. And then, hey, and then that these sides look like they could match up. You know what I'm saying? Because they would fold together.
Right.
Okay. All right, what is our cross section for made by the intersection of a triangular prism and a plane parallel to the base? So remember that the base is a triangle. If you need to, you can draw a little picture. Okay, so if we slice it parallel to the base, what are we going to get? A triangle. What if we went perpendicular to the base?
A rectangle.
Yeah, if we went perpendicular to base, it would be a rectangle. All right. What about the last one? What about a pentagonal prism and a plane perpendicular to the base? Yeah, a rectangle. Does anyone need to see it? Do we need to draw a picture? Yes?
Yes.
Oh my gosh, you just want to watch me struggle with drawing a pentagon. You guys are mean. Oh my God. I have faith in myself, just not my drawing.
If I was Deadpool, I'd be fun.
Why are you drawing?
Okay, well, it is what it is, guys.
Yeah, that would work perfect.
Okay. So if we are slicing perpendicular to the base, we're going to get a rectangle no matter what.
Yeah. No matter what.
All right, that's the end of it.